This conference will now be recorded.
Okay, once again, good morning all. We can start today's session. We are discussing about convolutional coding, and last class we have seen its encoder representation. That is, it is represented using the block diagram. That is, the elements of that representation are that memory element flip-flop and the adder elements. That adder is a XOR. Output of that adder is XOR addition. It is arithmetic to addition. Mode 2 addition is the result of that addition. And we have seen the operation of this convolutional encoder, and discussed about some parameters of the convolutional encoder, that the values dimension of the convolutional encoder, the values of the small letter n and the small letter k. It is the dimension of the code. It is a nk convolutional encoder. For example, 2-1 convolutional encoder, 3-1 convolutional encoder, like that. That is nk convolutional code. That is, which is termed as the dimension of the convolutional code. And here, that small letter k represents the number of message bit taking at a time, and that is actually generating the convolutional code corresponding to that much number of input message bit. That is, if k is equal to 1, we are generating the convolutional code corresponding to each message bit. And that small letter n represent how many number of output corresponding to that message bit. That is, k equal to 1, n equal to 2 means the 2 outputs corresponding to each message bit. If there are 5 message bit, then we get the total 10 output bits with n equal to 2. That is the dimension of the convolutional code, nk values. And code rate of the convolutional code encoder is k by n. And one another parameter, constraint length k, it is the number of shifts over which a single message bit can influence the encoder output. We have seen what is meant by that, that constraint length. And actually it is equal to the number of memory elements part of that shift register which is using in that convolutional encoder. And next, later we have seen the states of the encoder. In this constraint length equal to 3, there are in total 3 memory elements, and we can normally we represent it as m1 m2. Then status of the elements m2 m1 taken in this order: m2 m1, 0 0 0 1 1 0 1 1. It is, there can be 4 possible states. It is termed as the states of the encoder. We can represent these states as a b c d. And next is the important thing, how we can represent graphically this convolutional encoder. We can have 3 methods, that is code tree, trellis diagram, and state diagram. These are the 3 graphical representation, pictorial representation. So that once we have represented using any of these, we can easily find out the output sequence corresponding to a particular input message sequence. That is the significance of this representation. And in code tree representation, this initially we will have to aware of the what are the possible states of that convolutional encoder. Then what is the change occur if a particular input message bit, here we are considering binary sequence as the input, therefore either 1 or 0 is the input, Therefore, when 1 comes, then in a particular state, what will be the output bits? Similarly, what will be the next state of the encoder? Therefore, for this convolutional encoder, we can have 4 possible states, and we can have different conditions. It is either input bit 1 or 0. Therefore, we can have 8 different combinations of output and the next state condition. And here we have seen that example, some states, present state, and the input bit is 1 or 0. Then correspondingly, we have determined what will be the output bits, and seen what will be the next state. And coming to the exact representation of that code tree, we start with the initial state. Definitely, the state of the encoder will be A initially. Then the condition is next bit, the input bit can be either 1 or 0. Here the representation is, we draw a downward arrow if the input message bit is 1, or if it is if the input message bit is 0, then we draw a upward arrow. Then we represent a node, and at that node we represent the what is the next state in that particular situation. Here A is the state. Definitely the A will be the initial state. Therefore, with 1 as the input, next state will be B. We have seen how that comes. And along that branch, that path from A to B, we represent the output bits. We have seen here the next state is B, and output bits are 1 1. It is represented here. Like that, we can complete the all. We can represent all the possible combination as the code tree that is represented here. Here you can see states are A, B, C, or D. That is 0 0 0 1 1 0 and 1 1. These are the states of the encoder. Then starting from the state A, definitely the condition, the state, the status of that M2 M1 will be 0 0 initially, and upward path indicates input bit is 0, and next state will be A. And the output bits are 0 0. Then if the input bit is 1, we will have to draw the code tree like this, a downward arrow, and m equal to 1, it represents m equal to 1, and the output bits are 1 1, and next state is B. Then from this A is equal, A is the state, that is up to this we will have to represent, then only we get the all the possible condition. A 0 is the state, 1 is the state. It is actually is the repetition of this particular state. Then coming to this B, upward path represent input message bit is 1, and the output bits are 1 0, and next state will be C. And here B is the present state, then 1 is the input bit, then next state will be D, and output bits are 0 1. This we will have to prepare the table corresponding to all these combination, then only we are able to draw this code tree. Okay, then next possibilities are B. Here it is represented here, that is again we can represent here. Then coming to the present state is C, then 0 is the input bit, then output state will next state will be A, and output bits are 1 1. Then C is the present state, input bit is 1, then next state will be B, and 0 0 the output bit. Then coming to the state D, when the state is D, input message bit is 0, this path represent that upward path represent corresponding to the input message bit is 0. Then next state will be C, and the output bits are 0, 1. Then input bit message is D. Then output bits are 1, 0, and the next state will be D. This here, by making use of this particular code tree representation, we can see the complete representation, complete output sequence corresponding to a particular input sequence. That is, for example, if the input bit is like this: 1, 0, 1, 0, 1, 1. It is a 6-bit input combination. It is the input sequence. Corresponding to these 6 input bits, it will generate 12 output bits. We can consider initial stage is A. Therefore, and the input bit is 1 here, first bit. Then we can consider this path. Therefore, output bits will be 1, 1. Then in that state, that is input state, present state is A, input bit is 1. Next state will be B. Therefore, we will have to take this state here for the next bit. Then B is the present state now. Then 0 is the input bit. Therefore, we will have to take this path. Therefore, next bit will be 1, 0. Next 2 bits will be 1, 0. Okay. Then now the next state, that is present state, was B and input bit was 0. Then next state will be C. Therefore, now we will have to consider this as the present state. C is the present state. Then third bit is 1 here. Therefore, C 1 is the input bit. Therefore, next output bits will be 0, 0. Okay, then 0, 0. Then next state will be B. Then this B can be considered anywhere. It is up to this part, that is 3 stages of this code tree drawn. Then we can take any possible inputs bit. For here, now we have here at this B, present next state is B. Therefore, now the present state is B. Therefore, from this B, the input bit is 0. C is the state, then 0, 0 output bits. B is the state, next state, then B. Then C, corresponding to 0, 1, 0 is the output. Okay, 1, 0 is the output. Then next state is C. Then C is the present state. 0 next input bit is 1. Therefore, 0, 0 output bit. Then next state is B. Then B, coming to this B state, input bit is 1. Therefore, the output bits are 0, 1. Okay, in that way, we have generated the 12 output bits. That is a advantage of drawing this code tree. Once we have represented, we can easily find out the output sequence. Otherwise, we will have to if we are considering this convolutional encoder block diagram representation using these memory elements and the adder elements, we will have to check all the condition each time. It is input bit is 1, then x1 equal to m plus m1 plus m2, then x2 equal to m plus m2, like that. Then you will have to shift the bits contents of m shifted to m1, m1 shifted to m2, then next bit comes, then again x1, x2 we will have to determine. Therefore, once we have represented the convolutional encoder with this as this code tree, it is easy to generate or write the output sequence corresponding to the a particular input sequence. Okay, hope that you have understood. Okay, please say yes or no. Please write your response in the chat box.
Yes, sir.
Okay. Next, we can go to next representation. That is a code trellis. That is, or simply say, a trellis diagram. Here, it is we can say a simplified or compact form of the code tree. And here, in this code trellis representation, we represent all the states of the encoder twice. It is here A, B, C, D represented here. Again, once again, A, B, C, D represented. And we take it as current state and next state. It is all the possible. If there are 8 possible states, if the constrained length is 4, we can have 8 states for the encoder. Then we will have to represent that 8 states twice. One as current state, that is A, B, C, D, E, F, G, H, like that. And then again here next state, again that all the 8 states. Here in this convolutional encoder only 4 states, therefore we have represented as ABCD as the current state, ABCD as the next state. That is, we have represented all the possible states twice. And in this representation, take the first condition, A is the present state, then 0 is the input. Then we have already that table corresponding to all the possible output and the next state. If A is the present state, we can check this. A is the present state, 0 is the input, 0, 0 is the output bits, and the next state is A. And A is the present state, 1 is the input bit, 1, 1 the output bits, and B is the next state. Okay, here we, in this trellis diagram, we represent that transition from present state to next state as a continuous line. If 0 is the input bit, and a dashed line with 1 as the input. Therefore, here in this representation, A to A, this transition represent 0 is the 0 as the input bit, and we write the output bit along that path. Therefore, 0, 0 here. Then this dotted line A to B represent 1 is the input bit, and along that path we write the output bits 1, 1. Here 0, 0 output bit corresponding to 0 as the input, 1, 1 as the output bit corresponding to 1 as the input bit. Okay, similarly with B as the present state, we can see from the code tree. With B, 0 input, 1, 0 is the output, and C is the next state. Okay, and 0, 1 is the output bit corresponding to 1 as the input bit, and D is the next stage. Here it is represented. From B to C transition, a continuous line is drawn, and it represents 0 as the input bit, and along that path 1, 0 is written, that is the output bits corresponding to that transition. Then B present state, 1 is the input bit, then next state will be D, therefore it is drawn as a dotted line, and along that path output bits 0, 1 is represented. Similarly, other possible condition, C is the present state, this continuous line represent 0 is the input bit, and next state will be A, therefore it is drawn from C to A, and along that path output bits 1, 1 represent. Then if the present state is C, we can check in the from the code tree. C is the present state, then 1 is the input bit, next state will be B, and the output bits are 0 0, that is represented here. C to B transition with 1 as the input, therefore a dotted line, and along that path 0 0 as the output bits represented. Okay, then from D2 we can check from the code tree. D to C with 0 as the input, D to D with 1 as the input, and along that path 0 1 and 1 0 output bits. Here D to C with 0 as the input and 0 1 output bits. Then D to D, a dotted line, D to D, a dotted line with which represent 1 is the input bit and the output bits are 1 0. That is the trellis diagram representation of a convolutional encoder. That is, here the method we used is we represented all the possible states twice, one as current state and one as the next state. All the possible state A, B, C, D represented twice, 1 2, one as current state, one as the next state. Then considering all the possibilities from A to that is that transition corresponding to 0 as the input is represented by a continuous line, then input bit is 1, then that transition is represented by the dotted line. Okay, and along that path the output bits, here two output bits x1 and x2, it is written over that path, that branch drawn from one node to another node, that current state to next state. Okay, therefore that is the representation of the code trellis. Hope that you have understood. Okay, all of you please say yes or no, what is meant by this code trellis?
Yes, sir.
Okay, it is we are representing the all the possible state twice, and we draw the transition from one to other, and dotted line represent input message bit is 1 and continuous line represent 0 as the input. Along that path we represent the output bits. Okay, next we can move to next representation, that is a state diagram. Here and one more thing before going to this state diagram, here once it is represented we can easily find out the output sequence corresponding to input sequence, that is 1 1 0 0, like that the input sequence is given. We will have to check initially always the present state will be A, then if 1 is the input, then 1 1 is the output bit. Then we from this trellis diagram we can note that next state will be B. Then for the second bit we will have to consider the B as the present state. Then if 0 is the output bit, then output bits are 1 0 and the next state will be C. Then next we will have to consider this C as the present state. Then if A is 0 is the one input bit, then next state will be A and the output bits will be 1 1, like that. Then next A will have to take as taken as the present state, like that we can easily find out the output sequence corresponding to a input sequence. Okay, next state diagram. It is once again simplified, that representation, only that much, that state diagram. That is, here we represent all the states of the encoder only once. That is the difference compared to the trellis diagram. We have represented the all the all the states of the encoder only once. That is here A, B, C, D. Then the transition is the drawn from one state to another is similar to that trellis diagram. That is, if the input bit is 0, we draw a continuous line. If the input message bit is 1, then we draw a dotted line. This from this state diagram we can see A is the present state, then 0 is the input bit. Therefore, the transition is from A to A. We know if the present state is A and the 0 is the input bit, then next state will be A. Therefore, it is drawn from A to A. Then along that branch, we have drawn the output bits. That is here in this A to A corresponding to 0 as the input, and the output bits are 0, 0. Then if the bit is input bit is 1, then A to B, then output bits are 1, 1. Therefore, A to B here drawn a dotted line. The dotted line represent 1 is the input bit and the output bits are 1, 1. Then from B to C, if the input message bit is 0, and B to D, if input message bits are bit is 1, we can check B to C, B to D, and output bits are 1, 0 and 0, 1. Output bits are 1, 0 if 0 is the input bit and 0, 1 is the output bits when 1 is the input bit. Okay, like that we have completed the state diagram. Only difference compared to the trellis diagram is it is again a compact form, a simplified form. Once again, compared to that trellis diagram, we have simplified that representation. And once we have drawn the state diagram of a convolutional encoder, we can easily find out the output sequence corresponding to the input sequence. Okay, that's about these three graphical representation of the convolutional encoder. You will have to study this well. Reason is we will decode the convolutional encoder. One method is termed as known as Viterbi algorithm. In that, we are making use of this code trellis. Therefore, you must be thoroughly known about this code trellis representation. We are making use of this trellis diagram or code trellis in that Viterbi algorithm, which is used for the decoding of the convolutional encoder. Anyway, that's about the three representation: code tree, code trellis, and the state diagram. And we can easily find out the output sequence from any of these method, which is the three graphical representation: code trellis, trellis diagram, and state diagram. Later, we can see the time domain response analysis and the transfer domain response analysis. By making use of that, we can also find out the output sequence. Okay, that's about these three graphical representation. And here a comparison of the code tree and the code trellis. Code tree indicates the flow of the coded signal along the nodes of the tree, and trellis diagram indicates the transition from current to next state. Okay, code tree is lengthy way of representing coding process. Code trellis diagram is shorter or compact way of representing coding process. Decoding is very simple using code tree. Decoding is little complex using trellis diagram. That is the saying like that. We can continue in a particular path if we are using that code tree. We will have to switch back to that current state, that input state in each corresponding to each bit. Okay, anyway, it is not that much complex. Anyway, if we comparing these two, we can say like that. Code tree repeats after number of stage used in the encoder. Trellis diagram repeats in every state. In steady state, trellis diagram has only state. Then code tree is complex to implement in programming. Trellis diagram is simpler to implement in programming. That is a comparison of this code tree and the trellis diagram. Anyway, next you take this problem. That is, here this figure depicts a rate 1 by 2 constraint length n equal to 2. That is that capital K. Sometimes it is also represented capital N, that constraint length. And here that is given as the code rate 1 by 2 and constraint length 2. Convolutional encoder is given. You will have to draw the code tree, trellis diagram, and the state diagram of this particular convolutional encoder. This uh, simple because its constraint length is 2. That is, here it is represented only two memory elements, S1 and S2, and from this we can see here also given that the code rate is 1 by 2, means message bit is one message bit is taken at a time, and corresponding to each message bit we are generating two output bits, x1 and x2. And here we can write the equation for x1 and x2 as x1 equal to s1 and x2 equal to s1 plus s2. X1 equal to s1 and x2 equal to s1 plus s2. Okay, then regarding the states of this encoder, we will have to consider the state of the S2 only. Here the constraint length is 2, therefore we have only one memory element. We will have to consider for the states of the encoder. Therefore, this S2, the state of the encoder can be either 0 or 1. Therefore, only two possible states for this encoder. 0, S2 equal to 0, that is the first state. S2 equal to 1, that is the second state. Therefore, we can take it as state A and state B. Only two states for this encoder, 0 and 1. Therefore, now I am stopping here, and you can try this problem. We can complete the problem in the next class. Anyway, you try to draw the code tree, trellis diagram, and state diagram for this particular example. Here, x1 equal to s1 and x2 equal to s1 plus s2. That is the equation for the output bits, and the states of the encoders are only two states. Take it as state A and state B. That is s2 equal to 0, that is the state A, and s2 equal to 1, state B. Okay, with that we can stop now.